Okay, guys, welcome. Today we're going to talk about a little bit of an intro to the coordinate plane and some basic graphs. Okay, so by the end of this section, we're going to be able to talk about where points are in the coordinate plane. We'll talk about how to sketch some basic graphs, and we'll talk about how to also use the calculator to do that. We'll talk about how to estimate values of a function by looking at its graph, and also how to determine the domain and range of a function from its graph. And then finally, we'll talk about the vertical line test, which is used to determine if a graph represents a function. All right, so now a very basic introduction looks something like this. So the coordinate plane is drawn by basically creating two perpendicular lines that represent your two different axes here, right? So of course your horizontal axis is usually denoted by the x-axis, or whatever your independent variable is, or your input variable, and your vertical axis is usually the y-axis, which usually represents your output variable, right? Now, where those two meet, right, so right in the middle here, that's considered the origin, and that's also known as the point 0, 0, right? Now, if you move left or right from the origin, that's going to affect your first coordinate, right, which is your x coordinate. And if you move up or down, that's going to affect, of course, your y coordinate, right, which is the second component. All right, so that's sort of a very basic info as to how to draw the coordinate plane. Now again, so how do we talk about different locations in the coordinate plane? Well, the way that we do that is we use coordinates, right? Which is something that looks like x comma y. All right. Now your first coordinate, like we said, indicates the horizontal distance from the origin. And of course, positive numbers mean that you move to the right of the origin, and negative numbers mean that you move to the left of the origin. All right. And of course, there's an analogous version for the second coordinate, or the y coordinate. All right. And that indicates, again, the vertical distance from the origin. And then if you have positive numbers, that means you're moving up or above the origin. And if you have negative numbers, it means you're moving below the origin. Now, occasionally you will see that the coordinate plane is divided into four different sections, which are usually called quadrants. And these are the locations of the four different quadrants, right? So this top right one is considered quadrant 1, and that's considered quadrant 1 because most of the time we deal with quantities that are positive, and that's where both your x and y coordinate are positive, right? And then we proceed sort of counterclockwise to get the rest of the quadrants there. Okay, so now in this first example, we're just going to plot a couple points. All right, so if I draw a coordinate plane and we put some hatches on here, okay, so now we can plot a couple points. So for example, this first one, which I'll do in red, 2, 1, so I'm going to start at the origin. I'm going to move 2 points to the right, and I'm going to move 1 unit up. So that's my first point here. All right, let me get rid of that. Okay, the next point, which I'll do in green, so I need a -1, so that means I'm from the origin, I'm moving left this time, and then I need to go down 2.5 units, so I'm going to be somewhere right about there. All right, now the next point, oh, wait, I made a mistake here. That should be positive 2.5, so that's actually going to be up here somewhere. Okay, the next point, we have -2.5, -2.5, so I need to go left 2.5 units and then also down 2.5 units, and I lost my hatches there. 2, 3. So it looks like I need to go somewhere right about here. All right, and then last but not least, we have 3, -2, so that means I need to go right by 3 units and down 2. So that's going to put that point somewhere around there. All right, so that's sort of a basic intro to plotting some points there. Okay, so these are just some notes about the coordinate plane that we've really already mentioned. This really is telling us that the choice of using X, Y is not something that's set in stone, right? Not set in stone. Right, so you could use something like T, comma, A or something like that. You know, you could use M, comma, N, whatever the particular problem suggests. You could use different letters based on that. But usually, again, the common choice is X and Y. Right, but they sort of cover themselves by saying that may not always be best to say X coordinate, Y coordinate. It may be better to say something like first coordinate, second coordinate, or something like that. All right, but for the most part, we'll just use X and Y. Okay, now what we mean by a graph of a function is that we mean all the points where we have X comma f of X or X comma Y over the domain of a specific function, right? So this essentially means, so the graph is all of the points X comma Y that make a function a true statement. So it's a nice visual way to see sort of what's going on in a particular function. Right? So let's look at an example. All right. Now we want to sketch the graph of f on the interval 1 to 4 and then also on -4 to 4. So we're just going to do -4 to 4 and then that will cover both of them. Now, the most common way to do this, if you do not have a good idea as to what this looks like, and this one, to be honest, I'm not sure what this will look like off the top of my head. The best way to do this is with a table of values. All right, so that's where you plug in some X values, and from there you figure out, you know, what this thing looks like. All right, so it's best to do this if you have a calculator handy, just to get a better idea of, well, not necessarily a better idea, but to avoid making mistakes when you're plotting these points, right? So if you plug in a -4, it looks like in the top, so when X is -4, I'm going to get a 4 times, let's see, so we got a -20, and then we have -16 minus a 2, so it should be a -38. Actually, I have a better idea. So let's go ahead and we'll pull up a calculator. All right, so I'm going to pull up my calculator on the screen here. Okay, so here's my calculator. And one thing that we can do for this is, just so I don't have to enter this in a million times, let's go to our y equals menu. Okay, so we're going to plug this thing in. So I want to put my entire numerator in parentheses. So I'm going to need a 4 and then parenthesis, it looks like a 5x minus, and then an x squared, and then a -2. And then I need to close that and then close my entire numerator. And then I need to divide that by, again, want this whole thing in parentheses, x squared, and then +2. Okay, so then I'm going to enter that in, and now it's in the calculator. And now I want to go to second and table. All right, and that's going to make this a little bit easier for us because now they give us the values for each of these things. right? So now it looks like when I plug in -4, I'm just going to write these down and we'll come back to it. So I get a -8.44. For -3, we get -9.455. For both of these, we get a -10.67. For 0, we get a -4. For the next two, we get 2.667. And then we get a 1.4545. And then a 0.444. All right. Now, of course, you could also sort of cheat and see what the graph looks like here if we just press graph, right? And we're going to get something wacky that looks like this, right? So what we can also do, since we're just considering this from -4 to 4 for our domain, let's make our x min -4 and our x max +4, and then graph it. And that's sort of what we want to have for our sketch here, right? So I'll sketch this on mine, and then I'll show you what I have for it. So this would be something where, of course, it's not going to be perfect. All right, so let me bring us back to our notes screen here. Oops, okay, so that's not working. Let's try it again. Okay, should be back now. Okay, so if we were to find these with our calculator and then sketch it, we would get something that looks like this, right? And again, we can obviously use the calculator here to make this a little bit easier as well. Okay, anyway, so here we're given a graph that estimates the, let's see, for the 4-mile Hilly View race, shows the graph below where f of x is the altitude in feet when the race path is x miles from the starting line. So you're sort of seeing that this altitude is changing in this race here. So we want to estimate the altitude when the race path is 3 miles from the starting line. All right. Now, 3 miles from the starting line, again, that is telling us that x is equal to 3, right? Because if it's x miles from the starting line, it's 3 miles from the starting line. So I need to see, well, what's my y value when x is equal to 3? So it looks like that's where I'm hitting the graph. And then what's the corresponding y value? It looks to be about y equal to 250 feet. All right, so something like that. So again, this is just using to estimate, but rather than this is probably no doubt a complicated function to work with, rather than finding that complicated value, we can just use the graph to sort of estimate. Okay. And this is, again, just sort of highlighting the idea that I just did, but what we want to do is we want to draw a vertical line at our x value that we're interested in, and then wherever that hits the graph, we want to draw a horizontal line to the y-axis, and then that would give us the estimated y value. All right. So let's look at another example based on a graph. So in part A, they say, is 0.5 in the domain of f? Well, if I go to where 0.5 is, that's my vertical line at 0.5, and I don't hit a graph, so the answer, of course, is no. Vertical line at x equals 0.5 does not hit the graph. Right? In part B, they want to know, is 2.5 in the domain of f? And of course that will be, right? Because if you go to 2.5, you do hit the graph. So this is yes. Right? And again, vertical line at x equals 2.5 does hit the graph. Okay. Now in part C, we want to make a reasonable guess for the domain of f. right? So this is all of our possible x values. So something reasonable. It looks like my graph starts here. So it looks like we start at x equals 1. And where do we finish? Of course, it looks like here. So that would be x equals 4. So our domain looks to be from 1 to 4. Right? Because that's the set of all of our x values for which we have a graph that comes out. Okay. And again, this is sort of just explaining what we just talked about here. We said that a number is in the domain of a function if, when you draw a vertical line there, you do hit the graph. All right. So now we can sort of apply a similar approach to what we mean for the range, right? Now the range, again, remember, is the y values. So for part A, if I have 1.5 in the range, that corresponds to a value here. If I draw a horizontal line there, I do hit the graph. So 1.5 is in the range because the horizontal line intersects the graph. All right, now in part B, is 4 in the range? Well, 4 is up here. Of course, that's pretty easy to see no, right? Does not intersect. All right, now for part C, want to make a reasonable guess for the range. Well, what's the lowest y value? Looks like your lowest y value is at -1. It looks like our largest y value is up here, which looks like it's about 3. All right, so if your range is -1 to 3, we could write that in interval notation as -1 to 3, both with brackets. All right, because again, that's your lowest y value to your largest y value. All right, and this is just reiterating that method that we just used, right? So if you want to find the range, then you look for your lowest y value, your highest y value, and it's in your y value is in your range if a horizontal line will intersect your graph. Okay, now the last example here is sort of an interesting question. They want to know, is this graph a function? Well, again, what does it mean to be a function? So a function means that if we have an x value, that you get exactly one y value. All right, but there's a problem here. Because, for example, when x is 1, you get this y value, but you also get this y value. All right, so it looks like x equals 1 gives roughly y is equal to 1/2, and y is equal to 1 3/4, let's say. All right, so this is not a function. Right, because of that reason. Now, this leads us to an important thing here, and that's what's called the vertical line test, right? So you could go back to our example, and you can see that if you were to draw a vertical line where x equals 1, you're going to hit the graph there, and you're going to hit the graph there, right? And that was bad. So you have that a graph represents a function if any vertical line that you draw would only hit the graph once. All right, and of course it would not be a function if you can draw a vertical line that hits more than once, like we just did in the previous example. Now in this first example here, if I draw a vertical line here, if I draw a vertical line here, anywhere I have a vertical line there, I'm only going to hit once, so this is a function. All right, because each vertical line only hits once. Now, on the other hand, I can draw a vertical line here, that hits more than once. All right, so this is not a function. And you only need one of these vertical lines, right? So a vertical line hits more than once. All right, so this is not a function. All right, so that wraps up this video on looking at the coordinate plane and how it relates to graphs. I hope you enjoyed, and I'll see you next time.